Good afternoon to all the members. It is almost good evening. Now, I hope there is sufficient energy among all the participants to uh, participate in this event. Am I clearly audible?
Yes, sir.
Yeah, audible, sir. Audible.
Okay, I shall share my screen. I hope my presentation is visible.
Yes,
Visible,
sir.
sir.
It is visible.
Okay. Now, I should close a few things, I guess. No. Is it too much is on the screen?
Sir, we would request if it's possible if you could put that on slide share. Right, sir. It's visible.
Right. And then this black window on this side. Okay. I think I can make it very short. Okay. Now I hope this screen is clear to all the participants. Okay.
Yes, sir.
Today I shall be talking about many aspects of data science and the modern aspects of the data science that is related to artificial intelligence and Ayurinformatics. This title is AI, that is artificial intelligence hyphen Ayurinformatics. From knowledge to communication. This is the theme of the symposium web series that we are holding. I'm very glad to know that the Ayurveda College SDCH has started a new journal, and they are going to promote the science associated with the Ayurveda knowledge in many fronts. And also, I'm happy to note that they are starting to give importance to the data science. The data in Ayurveda is present in many formats that has to be slowly converted into a particular uh, a uniform theme such that the information technology tools can exploit that existing knowledge. That is one of the major challenges in the near future. For that, artificial intelligence is going to help. That is what I am hoping for. And we are also working towards that. So, in this context, when there is a invitation regarding a Lekhana series, I found it is very interesting because creating knowledge is one thing, and communicating with the colleagues is another thing. These two are not uh, natural; they have to be cultivated. I should be able to communicate with my colleagues. To communicate, I should have the proper. Not only that, I should have the knowledge. I also should have the proper communication skills. That is one thing which we do not cultivate in our schools and colleges. The communication skills, which are generally cultivated in Europe and American universities, or even in American and high school level, and even elementary school level, they teach to the students how to communicate with the colleagues and friends in the classes, outside the classroom, giving seminar lectures, writing articles. This is an art. Those people who cultivate how to create knowledge, how to churn out the existing knowledge to create new knowledge, they are all scientists. They are all excellent. While doing excellent work, we should also know how to communicate our excellent work. Otherwise, our work will remain with us only. So, in this context, I am trying to introduce these terms AI. AI is artificial intelligence. AI is Ayurinformatics. AI is analyzing traditional knowledge with the modern technologies like artificial intelligence. So, with this introductory point, I would like to elaborate on this in the coming few slides. How this knowledge is there with Ayurveda people, how artificial intelligence will help in this context with the help of Ayurinformatics. Bioinformatics is a relatively new topic, but it can grow very fast. So I hope that will happen soon, and that is already happening in many corners of the country. Only thing, we have to integrate all of them and put all of them into a particular platform. And there will be several organizations like CCRAS and AIIA and many other organizations are taking leadership roles in this context. So we will also contribute whenever there is an opportunity arising. So in this presentation, I would like to describe how to convert the modern concepts associated with AI into manuscripts worth communicating with the colleagues. We have got to realize that when a scientist is working, he is creating knowledge. He is trying to analyze all the existing knowledge. He is collecting lots of new evidences, and all these evidences he is going to organize in a particular order. Then, at that particular point, what is important for him is the truth of the knowledge. He is seeking new truth and new ideas, new concepts he is trying to establish. But when he is trying to communicate, he is an author. What is the main role of an author? Main role of an author is to be effectively communicate with his readers. When a reader opens up a research article and he decides to read, and if it is having the clumsy arrangement, the reader will immediately close the shop. He will close the article and he will go to the another article. He will not have much interest. So in this context, it is worth mentioning that if there is an article published, and a very well written article, how many people will read it? How many people may use it? How many people may refer it? How many people may actually take points written in that and utilize that for further extension of the knowledge? There are several organizations which are analyzing this kind of metadata. They create citation index, they create references, they create abstract services, and many other things. In this, one of the pioneers is the Chemical Abstract Service of the American Chemical Society. They are working for the last 130 years in an extensive way in preparing several indices, several abstract services, and then publishing journals and many other things. So, but according to them, they are telling that their analysis is indicating that when an article is written, suppose it is a very good article. Uh, what I mean by very good is that it is not a routine article. It is not a pioneering article. It is slightly better than average, and maybe we can give 60% marks to such an article. For such an article, the analysis says that there may be a maximum of 200 people open it in the entire world. 8, 8 to 9 billion people are there in the whole world. Out of that, only 200 people may open it. And then once they open it, they uh, they read, only a few of them read the title, abstract, and the conclusions, and simply immediately move on to the next article. They may not spend too much time. How many people actually will spend time on an article, very good article, is less than 50 people. This is statistics given by American Chemical Society. So in that context, what is the role of an author? The role of the author is to create uh, such a platform for the reader to get attracted. Why, if 200 people are opening it up, they should read. All of them should read. They should not immediately close it. They also tell others that, okay, I have read a very important article. Please do refer it. And then all of you also read it. This is very interesting. So the main role of the author is to create uh, such a platform. The title itself, the abstract itself, the figures, the graphical abstract, everything should be sufficiently attractive that the reader should feel, okay, I am interested. Now I find title is nicely written, so I want to know little more. Abstract is informative. I want to go more into the details. Then introduction is very well written. That means the authors have done sufficient homework. That means I want to read the rest of the article. So we should have the elements which will attract the reader into the entire all the paragraphs of the article. Then only we can say that the article is successful. So I would like to tell that how we can develop this in the field of artificial intelligence applied to Ayurinformatics. How we may be able to develop some of the skills. Hopefully, I will be able to communicate this. Whatever is in my mind, if I can effectively place in front of you, it will be a success story for me today. Okay, let us look at what is Ayurinformatics. We all know about the Ayurveda. I am sure most of the um, participants in this web series are experts of Ayurveda. So I will not tell too much about Ayurveda. What is it? I will tell that information technology has got many aspects. Many aspects are being adopted by every part of the science, every part of the society, every human being is adopting information technology. That means Ayurveda experts also will be adopting it, and they are already adopting in many ways. But how to go deep into science with the help of the information technology? These attempts are being made. A few attempts are successful. For example, in Ayurgenomics, a team from IIT Jodhpur is working seriously on this. Then artificial intelligence in Ayurveda. A team from Chennai is AI, ayurai.com. They are working very sincerely on this particular topic. Similarly, a handful of experts are working in a deep-rooted level, and I invite all of you to take initiative and then do deep-rooted research and contribute significantly in this direction. The opportunities are infinite in this direction. So for that, we in sitting in a pharmaceutical institute at Naipur Mohali, we take help of the topic called pharmacoinformatics. This is a topic which Naipur Mohali initiated about 22 years ago, and it has taken off very well. In the last 22 years, the topic of pharmacoinformatics has grown from making baby steps in 2002, 2002, 3 to today, it has grown into a very well matured scientific topic. The strength behind this is chemoinformatics. bioinformatics. And then the push for this particular growth is coming from the growth in artificial intelligence across the world. Then there are topics like Ayurgenomics, metabolomics, immunoinformatics, neuroinformatics. There are many scientific topics which are helpful in applying the information technology for Ayurvedic knowledge. So this is what I perceive, and for this reason, we have conducted to promote this. We conducted two conferences already. One is on online conference, another is at Naipur Mohali in the year 2024. Before we took initiatives. Already, Government of India promoted many of these things in the form of TKDL, Traditional Knowledge Digital Library, and Dhara, Ayursoft, Ayur AI, and like that, many initiatives were already there. Our job is only to mm, take it to the one more step towards the success story. That's what we are trying with the help of pharmacoinformatics at Naipur Mohali. Now, I would like to introduce some of the topics of modern information technology. That is, artificial intelligence. All of you are hearing about it. What is this? Is it a difficult task or is it an easy thing? What is the history of this? What are the various components of artificial intelligence? How it may be useful for Ayurveda knowledge creation and knowledge analysis, data analysis. That we'll look at it in the coming few slides. John McCarthy was the first scientist who coined the name artificial intelligence. This is that can mimic the human intelligence. Later, there was lots of growth, but there was a lull period. Again, there was a growth somewhere in 90s, 1980s. There was growth in Ayurveda, artificial intelligence. But again, there was a dull period after 1994, 95. There was not much growth. It took another 20 years before the speed in artificial intelligence has actually kick-started. Now, for the last 10 to 12 years, almost every branch of the world, whether it is service sector, whether it is science sector, or whether it is technology, everybody started using it. And now, currently, there is tremendous growth in Ayurinformatics and in as well as in artificial intelligence. So as a result, pharmacoinformatics adopted artificial intelligence in a big way across the world. I will give some of the examples. Now, same speed and same growth is possible in Ayurinformatics and Ayurveda with the help of artificial intelligence. So this is some of the historical points. So let us see what is happening in Ayurveda. In parallel to the artificial intelligence in IT field, in the field of Ayurveda, we can consider this Yukti Pramana concepts. And then they are all rooted in Indian philosophy. They all emphasize on the application of logical reasoning and strategic thinking to solve complex problems. At the same time, at the same time, Ayurveda suggests let us look at the knowledge in a holistic view. Don't look at it as individual compartmentalized components. That means, for example, my subject chemistry. Inside chemistry, we talk about analytical chemistry different, organic chemistry different, physical chemistry different. Why to compartmentalize? Look at whole thing as chemistry. And why even to compartmentalize between physics and chemistry and computer science? Take a holistic view of all sciences. That is what is promoted by Indian philosophy and also the Ayurveda science. So they look at everything in holistic view. That is actually the strength of artificial intelligence. Artificial intelligence tells that all the knowledge can be integrated and then new concepts can be generated in a holistic view. So as a result, I believe that the concepts in Ayurveda and the concepts in artificial intelligence are overlapping very much in the sense that they are both of them are adopting a holistic viewpoint. So Yukti Pramana based Indian philosophy and the holistic viewpoint of artificial intelligence can be taken into advantage, and AI can grow in the coming few years in an extensive way. The AI techniques are utilized in drug repurposing, drug target identification, toxicity prediction, diagnosis of the disease, and many ways. Nowadays, AI has entered into all sub branches of medicine, including Ayurvedic medicine. So automation is possible. Robotics are also being introduced in medicine, and virtual assistants are being created. Softwares are being written, and likewise, several things are happening. Why not in Ayurveda? Yes, Ayurveda versus information technology. Let us look at the Ayurveda science. The science of Ayurveda was always adopting the top-down approach. This is what humans have adopted for the past centuries because this was naturally occurring. Only recently, there is a new approach that was introduced, that is bottom-up approach. Starting in physics, starting 600 years ago, they started the bottom-up approach. That is slightly different from the top-down approach. That is, top-down approach is, what is it? Discover drugs by looking at their effects on their biological systems by generating numbers through trial and error. Bottom-up approach suggests that what makes tick the molecular level, deconstructing the atoms and orchestrating their interactions with the human body. That means the first collect lots of data and from there extract knowledge. That is top-down approach. Bottom-up approach is that try to find out the hypothesis, try to derive an equation. From the equation, you generalize the concept and then apply the concepts on the broader level so as to expand the scope of the principles. So these two approaches appear to be opposite to each other, but they collaborate extensively. This is the way the philosophy of the science can be described. In pharmacoinformatics, we are adopting the topic called bottom-up approach. That means we come up with the hypothesis from the initial data points that we collected. And from those, we try to apply these hypotheses on larger number. Then we derive rules. From the rules, we come up with the principles. From the principles, we come up with the formulae. From the formulae, we derive laws. And then the laws we try to apply on more and more examples. So this is the bottom-up approach in pharmacoinformatics. But Ayurveda always adopted the top-down approach. Then how to integrate these two? This is a challenge. If we understand this philosophical level question, how we can adopt Ayurveda versus pharmacoinformatics, then we will say immediately succeed. Very quickly we can succeed in Ayurinformatics. Then how artificial intelligence will help? It will help in making the best use of both the approaches because it can understand and it can derive new concepts. It can suggest new concepts by analyzing the data. in a holistic way. If a human is interpreting the data, he will have to look at segregated way. First, he will classify the data into various components and then try to understand. But when the artificial intelligence is trying to understand, he will say that give me more data, give me more data. The more data you give, it is more easy for the artificial intelligence to succeed. That means it will not segregate things, it will integrate the things. It will not differentiate, it will integrate. In terms of the calculus, we can define like that. So that is where artificial intelligence will help. A need to identify advantages and developing tools to exploit both the approaches is existing, and all these details were very well explained in this article by Professor Joglekar, and this article was published in a journal called Wave Function in the year 2017. I hope all of you will get a chance to read this very interesting article on how Ayurveda can exploit this top-down approach versus the bottom-up approach. If we come back to the artificial intelligence and machine learning, what is the history? History, it started with in 1950 when a scientist called Alan Turing suggested a test called Turing test. In 1956, the term artificial intelligence was coined, and then the perceptron word was introduced, which is being called as a neuron today. The artificial neuron is the old term for that was perceptron. And then a language was created called Lisp language was created for artificial intelligence in 1960s. Another new language was created in 1972. These are some of the milestones. In 1990, machine learning became very popular. Before that, there was something called knowledge-based approaches. For that, Lisp and Prolog were very, very useful. Whereas when the machine learning approaches, including neural networks, were introduced in 1990s, there was different type of success in artificial intelligence progress. Then this was further adopted with the help of the chess game and other deep-rooted thinking processes. Deep neural networks were introduced somewhere between 1997 and 2000. This is a fundamental growth. But this was all being done by only experts. It was not publicly available to many people in those days. Now, after 2000, people started appreciating them. General public started appreciating. After 2010, it became more common for all walks of life started realizing how we can exploit the advantages of this topic called artificial intelligence. Somewhere in 2017, first approved drug by FDA was realized in the year 2017 uh, with the help of the deep learning algorithms. Based on that, gastroenterology studies were carried out between 2018 to 2020, and AI-based design of a new drug with the help of drug repurposing approaches was introduced in 2020, and now it is all the drug discovery people are adopting a topic called generative artificial intelligence approaches. The modern terms are explainable artificial intelligence, generative artificial intelligence. Likewise, there are several new concepts are being introduced. The speed with which the fundamentals of artificial intelligence are growing are very extensive speed. For example, what happened in our own lab, we started to learn something called LSTM technology 2 years ago. We succeeded in learning after 1.5 years of expertise, churning out the ideas. We wrote good articles on this topic. But nowadays, when we submit the articles based on LSTM, people are telling it is old technology. It is more than 2 years old. Let us adopt something new, publish on new technologies. Why are you using the old technology which is 2 years old? So that means the speed with which artificial intelligence is growing, we can realize that 2 years ago, whatever is smart became old today. So let us be uh, faster than the growth. That means we have to quickly adopt whatever is happening today and quickly get a result within coming 3 4 months, so that we can uh, effectively contribute in this area. Okay, so European, let us see that somewhere around uh, 120 years back, everybody in the whole world was using only top-down approach. Whether it is allopathy, homeopathy, Unani, or whether it is Ayurveda or whatever science, they were all adopting only the top-down approach. Only recently, that is only 120 years ago, the bottom-up approach, taking the help of physics, chemistry, and biology, the bottom-up approach entered into the pharmaceutical sciences. Until recently, till 1970s, that is 50 years ago, the top-down approach as well as bottom-up approach were going very parallel to each other. Even today, it is happening in drug discovery science. Uh, so, so it is not too late for us to adopt this. Only 40 years ago, importance of molecular biology was realized in drug discovery. Only 20 years ago, the computational methodologies and the information technology applications were recognized in the form of pharmacoinformatics. If we look at that, therefore, it is not too late for Ayurinformatics to grow. As I told earlier, many people are working in some small sub pockets, but there should be collective effort in this direction, and I am sure that will happen soon. Almost all institutes of CCRAS are adopting it. Almost all Ayurvedic colleges are learning this, and uh, and that will that is where there should not be any hesitation. So all the experienced doctors in Ayurveda, all the experienced scientists in Ayurveda, they they are getting many good results without adopting information technology. But if and when they adopt information technology, they will produce good results at a faster speed. So that is what my request to all the experts. So adopt this artificial intelligence as well as Ayurinformatics in a big way in your day-to-day patient care as well as in day-to-day research efforts. So now, from now onwards, I will go very fast. I will move slides very quickly because in healthcare, you can visit this kind of website given here on the right-hand side bottom corner. They people are working on this. University of Rochester is working. Let us learn from them. Their time, Ayurvedic is being used in many ways. For example, information and communication technologies and Ayurvedic knowledge, data mining in Ayurveda, Ayurvedic text mining, Ayurvedic laboratory setup, applications in Ayurvedic education systems, development of new research methodologies in Ayurveda, statistical hypothesis, testing the Ayurvedic data. Likewise, several varieties of things are being adopted. Statistical hypothesis using bioinformatics, clustering of the Ayurvedic medicines, disease in identification using informatics, integration of what is that Internet of Things in Ayurvedic practice, fundamentals in Dravyaguna using Ayur pharmacology, and applications of artificial intelligence, Ayur genomics. Likewise, many varieties of things are being adopted by the Ayurvedic people. So, how we can pitch in? Can I go into the statistical hypothesis, or can I go into the disease identification? This is all possible because of your background. Your domain knowledge can help in which of these concepts you can easily adopt. That is how we can jump into this. So, but in our lab, what we are doing, we are looking at the molecular informatics at the molecular level. 1D information, 2D, 3D, 4D, 5D. There are lots of varieties of dimensionality in molecular level data. That's what we are adopting in our laboratory. We are adopting molecular docking in Ayurinformatics, molecular dynamics, chemoinformatics, bioinformatics, virtual screening of phytochemicals, also covers the integrated topics, network pharmacology, higher genomics, wherever molecular level information is required, that is 2D structure and 3D structure information is required. There we are contributing from our laboratory. Holistic view in Ayurveda. Clinical perspective, holistic view is there. Patient perspective, holistic view is there. Formulation perspective, holistic view is there. All of them put together in Ayurveda. For example, a clinical practitioner in Ayurveda is also developing formulations. In allopathy, formulation scientist is different, pharmacology scientist is different, then the medicinal chemist is different, informatics scientist is different. But in Ayurveda, it is not like that. All are doing all the things. That is why I am telling, as a clinician is also scientist in Ayurveda science. In Ayurveda, clinician and pharmacist are not distinguishable. Ayurveda, in general, they cannot be distinguishable. Ayurveda doctor is knowledgeable on modulating the formulation. He is also a drug discovery scientist. He can handle Ayurvedic drug dispensary. Patient care is not limited to immediate symptoms observed. They also related to history of alignment, history of therapies, food habits, social environment, upbringing, all those things. Similarly, formulations in Ayurvedic medicine is not about one or two molecules. It is about the mixture of several natural resources, their synergistic ingredients, and in disease. Research is required to represent holistic approach using the central dogma of information technology. So, a holistic view is possible in AI. Ayurveda adopts holistic view as well as artificial intelligence also adopts holistic view because the neural networks, deep neural networks, they analyze lots of data, and then the lots of data is not possible in a specific subtopic. It is generalized subtopic only. Lots of data is possible. So that is where holistic view is coming out. So thus, this I already explained. I will not go into details. AI models learn patterns directly from the data. The concepts of Yukti Pramana are directly resonating with the AI approach in problem solving. AI algorithms process and analyze data, enabling the system to make strategic decisions and predictions akin to human-like intelligence. Therefore, AI, in its essence, aligns with the principles of Yukti Pramana. Thus, AI and Yukti Pramana share this fundamental link. The strategic algorithmic processing is central to AI, is also central to the Yukti Pramana. All these details were written in this particular journal article, Journal of Indian System of Medicine 2024. I hope you will be able to read this. Trisutra of artificial intelligence in Ayurveda. We need to know about the human data, disease data, Ayurvedic treatment data. All of them can be integrated in terms of their details. Uh, this is being practiced in AI. Ayurinformatics and artificial intelligence can be very well utilized for drug discovery, drug design, drug toxicity, drug repurposing, drug metabolism, and things like that. When we come back to artificial intelligence, there is something called uh, uh, flow of data. For example, artificial, narrow intelligence, general intelligence, and super intelligence. Some people are dividing that into this, but then integrating them again. In 1990s, prologue and release I already mentioned. After that, AI, artificial intelligence, drug design is being adopted in many ways. Machine learning methods, knowledge-based method, artificial neural networks, ANN, deep neural networks, DNN, convolutional neural networks, CNN, genetic algorithms, fuzzy logic, support vector machines, like that. I can give details of each of them, but I will not have much time to do that. So I will simply mention this kind of general figures. For example, if I consider this entire circle is artificial intelligence, within that, machine learning is a subtopic. Within machine learning, there is KBS, indicator algorithms, deep learning, fuzzy systems, support vector machines. Mostly support vector machines and ANN, they all adopt statistics. Statistics is the basic uh, fundamental mathematics behind artificial intelligence. If we realize in India, Indian Statistical Institute, Calcutta, was a pioneer of artificial intelligence starting from 1980s. Uh, so it is one of the best recognized. That will tell us how statistics and artificial intelligence are very much thoroughly integrated with each other. So knowledge-based methods, this we are using. Actually, Google, which we are using every day, is actually called KBS, knowledge-based system. Similarly, many things we are using. Grammarly, we are using, and we are using the many tools of language processing and the voice processing nowadays. So that is all practical with the help of KBS. Now, I don't want to elaborate this. And genetic algorithms. This is about the how human genetics is emerging. If I understand that and adopt it in the form of computer programs, then that is known as genetic algorithms. We can do molecular docking with the help of genetic algorithm principles. We can do many things using the principles of genetic algorithms. Uh, Compounds, I will not elaborate on this because I am running out of time. I will go to the next slide. Machine learning. Machine learning is one part of artificial intelligence, but it requires lots of data as input. Machine learns from the data that we supply, just like how we learn from our alphabet. We learn at the age of 5 how to put alphabets together and make words. From there, we learn how to make sentences. From there, how to make paragraphs. Then we learn how to write essays. From there, we learn slowly, gradually, human is progressing. Similarly, how we are doing it? By observing. If I am able to give a very effective lecture today, because I observed how people are giving lectures in my high school, in my college, during my PhD, I have observed many top class scientists. I try to adopt something. Not everything is taught to me in the form of examination and lecture. Uh, it comes to us by observing many good speakers. We will learn how to give good lectures. Similarly, our artificial and machine learning tools, they learn from more and more examples that you provide, it will learn more. That is machine learning. Now, types of machine learning: supervised learning, unsupervised learning, reinforcement learning. There are many other details in this. Support vector machines is one of the techniques which is mostly based on statistics. Fuzzy networks is the one which allows for some kind of fuzziness. According to the physics, everything is predictable. But Heisenberg uncertainty principle introduced there is something called fuzziness into the into science. So similarly, that means there is some haziness, some uncertainty in the data. So that is all. For example, you go to an astrologer, he will tell on March 15th at 7 p.m. this boy is going to get married. How he will predict? Just by looking at the lines on the hand, he will tell that something very specific. Then on that particular day, he will say that, I told March 15th at 6 p.m., but I did not tell you the year. It may be 2026 or 2030. I will not tell you. There is fuzziness in that. So, this is somehow, there is fuzziness in day to day life. The same thing is incorporated into data. That is the concept behind fuzzy networks. So, now again, neurofuzzy networks, adaptive neurofuzzy networks, there are many varieties of that. Machine learnings are linear regression, logistic regression, support vector machines, decision trees, random forest, then boosting algorithms, XGBoost. Likewise, there are several algorithms associated with common machine learning algorithms. This is the slide on linear regression. This is straight taken from statistics. Logistic regression is when the data points are too many, how to classify them. We can use the logistic regression, multiple linear regression, partial least squares. There are several algorithms associated with that. Logistic regression has got many examples that I am not giving here. Decision trees, how to take decisions if and when, if a particular thing happens, a decision is different. Another thing happened, decision is different. So likewise, how to segregate based on the knowledge that we are supplying. Mostly KBS is based on this decision tree approach. Random forest approach. When a tree is expanded into many sub branches, it is called a random forest. Then neural networks, how our brain is working. If I can write a computer program very similar to what our neurons are working in my brain, that is called artificial neural networks. There are networks like that as shown here. For example, this is called a network. This kind of network, there is input layer, there is output layer, there are hidden processing layers, and when data is moving forward to backward, there are several algorithms like back propagation, feed forward. Once we adopt with the help of a neuron, each of the neuron may have a step function here, and using this kind of step function, we can take decisions whether information will go from here to here or not, whether it is 0 or 1 from this neuron to another neuron, all that can be handled with the help of neural network. That is exactly our brain is working in the same way, and our software can also work in the same way, and thus we can contribute. This is architecture of a neuron in a neural network, and each of them is deciding whether to send a signal or not to send a signal based on the weightage. For example, I will uh, I will give a very simple example which we already know whether to bunk a class or not. The students always want to bunk a class. If Professor Bharatam is giving boring lectures, let us bunk the class. Let us go to Shah Rukh Khan movie. Whether to go there or not, they take a collective decision, all the students. So that is where the weightage comes. whether Bharatam gives a interesting lecture or boring lecture. Based on that, they will take decision to bunk a class or not to bunk a class. So likewise, also they take into account whether interesting cricket match is happening. Suppose Mohali cricket match is happening. Naiper students may say that let us ask Professor Bharatam to give lecture tomorrow. Let's go to cricket match because both are equally accessible to them. So likewise, there are many decisions. That is all based on weights, weightage. How much weightage they are giving uh, to cricket match versus the classroom. Based on that, they will take decisions. Similarly, artificial neural networks take decision like that. So this is one of the fundamental concepts in machine learning. Then this is expanded into deep neural networks. In deep neural networks, it is a part of the machine learning, and then it will. There are many algorithms that are being adopted. So this is how a deep neural network will look like. It will have many input layers. In the input layer, there will be many neurons. That is maybe 1024 neurons, or maybe 5 times more than that sometimes. The number of neurons in the hidden layers are also very heavy, and number of the hidden layers are also very large in deep neural networks. And there is an output layer, and the output layer will uh, help in taking decision. Data goes to and fro in the training process. So there are many deep neural network approaches: LSTM, CNN, RNN, GAN, generalized adversarial neural networks, autoencoder, transformers. Many things are known because this science behind this is growing very fast. Uh, I will not elaborate on that, but I will quickly move to the quickly move to the this is 1D, 2D, 3D representation of the drugs. From there, generative artificial intelligence was adopted, and this molecule was suggested as a as an antibacterial drug using a generative artificial intelligence. Similarly, the NPC classifier, natural product classifier, artificial intelligence, and AI people, they are exploiting the knowledge from NPC classifier extensively. There are databases available, and then there are tools available. The NPC classifier, this is a freely available tool. You can adopt it, and you can learn a lot from these journal articles. Then similarly, highly potent uh, anti-osteoporosis drug was identified using artificial intelligence. The discovery of novel anti-obesity phytochemicals was also carried out using artificial intelligence, where the some of the phytochemicals are taken from Ayurveda. Similarly, now I will come to the communications. The main goal of the science is to communicate. If I cannot communicate, all my science will die down in my laboratory. That is where this Lekhana series was introduced by this SDACH. Once we solve a problem, the main goal of an author is to communicate ideas effectively. For reader is important for him. So, for a scientific author, both problem solving as well as reader are more important. So, how to do that? Research deals with problem identification, understanding the problem, experiment, observation, interpretation, and finally, communication. We cannot ignore that part. Ideas should not be volatile. That means we have to write all ideas that we get. Whenever I get a new idea, I should write it with a paper and pen. Then it will not be volatile. Should always be put in black and white on a paper pen. We should always be writing down. should be expressible through all possible communication channels. It may be through PowerPoint, it may be through articles, it may be through lectures, it may be to sermons, or whatever format you should be able to. It may be through jokes. We should be able to communicate our knowledge. It should not be only suggested to others, it should be put to practice. Should not be should be quickly put to practice. Should be not be a very should be a very high quality. We should not leave it at okay, I made one attempt, I leave it there. We should have perseverance in pursuing the idea. Should be challenging enough. That is where my teacher, Professor E.D. Jemmes, taught us that whenever you have an idea, start writing on it. Write a manuscript the moment you get an idea. Once you get more data, you modify the manuscript. Once you get more and more facts, you keep on modifying your manuscript. That is why the writing of the manuscript and working should go parallel to each other. So, problem identification and problem solving. How to identify the problem? If I cannot identify the problem and if I cannot express the problem properly, I will not be able to solve the problem also. This is the simplest clue. Any successful scientist is able to communicate with himself. First, he has to convince himself whether the problem is realistic or not. So, likewise, I hope I have some more time. Another 3-4 minutes, I will conclude. Problem understanding. Once I understand the problem, I have to go to the next level. How to identify, how to solve it. If I fail in that, I should go back to understand the problem. Once I understand these first two steps, I should go to the apply the methods on the problem. If I fail here, I should go back to the understanding the problem. Generate the first solution, go back to the understanding. Optimize the solution, first go back to the original. Don't go backwards to the first solution. Go back all the way to the understanding of the problem. This is how we will be able to solve and we will be able to communicate. So each time we make one step progress, we should go back to the did we understand the problem correctly or not? This is where a successful scientist is always adopting this kind of approach. Interpretation. Many results are there. Only few of them are communicatable. Only few of them can be written into paragraphs. Only few of them can be written into a manuscript. What are those? That is the knack of an author. And only a expert author can realize this. That is where this Lekhana series will help in realizing that. First, we have to generate hypothesis and we have to write the ideas from the hypothesis. Reasoning leads to science. Logic should not be buried in the facts. Too much data, we may lose the track of the story. So we should be able to have a proper data points as well as the proper mixture of the storytelling. So knowledge should lead to wisdom. No, that is where the author is coming into picture. If only the author is able to communicate, knowledge will lead to wisdom. Otherwise, it will become data. It will become tables after tables from where every reader may not be able to interpret. That is where the author is important. Validation of the hypothesis is required. Scientific writing in Ayurveda we can practice. Plant source, organ based information we have to collect. Produce procedures employed in extracting the data, whether it is chromatographic details or whatever details that we have adopted. Purity of the extracted samples and the kind of processing that we did, all these things have to be properly described in in paragraph wise. Each paragraph should give a message. Each section should give a should give a message. Finally, conclusion should compile message 1, 2, 3, 4, 5 of an article. So when we organize the article in this way, we will be able to write excellent research articles. And thus, I would like to come to conclusion here. Scientific writing in uh, computational methods should be describing the software adopted, algorithm employed, and the data that is generated, how the hypothesis is generated, and the calculation details, and then the concept that is emerging from the computational methods. So, in conclusion, I would like to convey that artificial intelligence is a modern science. Ayurveda is an excellent science. We should be able to integrate these, and it is very much possible because both of them are adopting holistic view. Communicating the ideas is to be practiced. It does not come automatically. We have to practice how to write articles, how to write essays on the knowledge that we have collected. We should have patience. First thing is that if I don't have patience to write a paragraph on the knowledge that I have, what is the use of it? I have, that is where the authors are very important. That is the basic art that we have to teach to our students whenever we uh, work. AI shall have excellent impact when nurtured properly, and that is being practiced across the world in small pockets. And I am sure in the coming 3 4 years it will be adopted by everybody in field of Ayurveda. Thank you very much. With this, I will stop. I will be happy to take questions.
Thank you so much, sir, for that fascinating session connecting classical concepts with computational intelligence. We'll now take a few questions from our participants. Please post your questions and your queries in the chat box. Don't unmute yourself. We request everyone to post their queries in the chat box. Sir, we have a question here from Anita Vanjari. Sir, can we work out these techniques for herbo-mineral drugs? So when we have herbo-mineral formulation.
Yes, it is a very important question related to bhasmas also. When we talk about mineral, if we take only metallic elements like sodium, potassium, and magnesium, then we may not be able to make too much progress. But inside a bhasma, if the particles are present in the form of an organometallic compound, then it is easy to adopt. That means we need to do little bit of inorganic chemistry and organic chemistry so as to find out what kind of complex environment in which the mineral is present. That means if magnesium is complexed with an organic compound, and then there is a coordination bonds there, and if I can understand that kind of knowledge, that knowledge can be easily supplied to artificial intelligence tools, and then we can generate more and more information.
Thank you, sir. We have two more questions.
Yes.
One by Dr. Giridhar. Sir, what are the available AI tools and Ayurinformatic databases to learn?
There are a few tools available online, but they are all emerging, they are evolving. They are all the beta versions. So you need to utilize, you can utilize these tools but you have to do with a pinch of salt. That means you should be very careful in interpreting the results from that at this particular point of time. After they are all evolving, they are all becoming more and more reliable year after year. So at this particular point of time, I will suggest that any tool available online, you use it, but don't trust the result coming from that as a black box. You integrate your Ayurveda knowledge and then re-verify, validate the result coming from the Ayurveda tool is worth suggesting for the patient, worth going to into the science of Ayurveda. So I will not suggest any software today, but because I myself am not 100% confident on any of the tool available. So hopefully these will emerge in the coming few years, and we can suggest this tool is better than the other tool like that. Today I cannot even make such kind of comment.
Thank you, sir. Another question by Dr. A. Ramakrishna is where can we get more knowledge on basis of network pharmacology and molecular docking and bioinformatics?
Well, there are a few research articles that are published. We also published a few reviews. I can send my review articles. There are references given, section wise, they are described. Network pharmacology, specific success stories are described, and molecular docking success stories were also described in our articles. I will share. If you please send a email to me, I will share that article, and from that you will be able to pick up.
Sure, sir. We'll convey our group members likewise. There is another question we have from, they haven't named themselves. So it is, sir, what if we are working on old technology like SVM, RF, but not on new topics? So at that time, can we go for publishing work or not?
Their scope is very big. The SVM based research articles are also being published, and the molecular docking based also are being published. So these are all very robust statistical approaches. If we understand the statistics behind it and then appropriately interpret our result, then nobody can stop our publication. But if I use it as a tool, okay, I have quickly done something using a algorithm. I got this result. Please publish it. The editors will be very much annoyed. Like Kulver people who are promoting our JTAC camp today, they will be concerned whether this person has he understood the science behind the work, or he just got some superficial research that he did. Base, that is going to be the major block. It is not the technology. SVM is not going to stop you or promote you towards the publication. SVM will give a tool. How we are adopting that tool for my Ayurvedic knowledge, that is going to determine whether the paper will be published or not. So please pay attention to that bridging topic, and you will succeed. Everybody will succeed.
So another query by Anita
Yes.
ji only. Can we have any case study for the herbo mineral formulation?
Uh, I myself tried on one example, Shilajit related. We are still working on it, but there are, I did not find many robust studies. Many studies, some studies have been reported, but I was not able to follow them because I wanted little more in-depth knowledge in this. So we are making one attempt. When we succeed, we will share with everybody.
Thank you, sir. Thank you so much for an enlightening session.